Solving log equations is one of my favorite things to do because I love how complicated it looks and how simple things boil down to when you use the properties. So I just wanted to look at an example here with you. If you use the properties, what you can do. So here we go. We have solved the ln of the quantity 3x minus 2 plus the natural log of x minus 1, and we're going to see where that equals 2 ln of x. All right, and let's start to see what we can do with these properties. So I'm just going to start, and I'm not using, they're going to use the graph in your book. We're going to do it a little bit more complicated. So let's see here. I'm thinking I can use the product rule. That's what I start off with. So I have the ln of 3x minus 2, and I'm going to add a bracket here because that addition, right, this addition can be rewritten as multiplication. So that's what I'm going to do. And then as I rewrite the other side, I'm going to go ahead and apply the power rule, and I'm going to leave it as the ln of x squared. All right, then I can go ahead and do that multiplication. So I'm going to have 3x squared minus 3x minus 2x plus 2. And then does anybody kind of see, well, I'll go slower. I won't go fast. And this is still going to equal the ln of x squared. And now I'm going to say, well, let's just set the whole equation equal to 0. So I got 3x squared. This is going to become minus 5x plus 2. And I'm going to subtract the ln of x squared. And I'm going to set this whole thing equal to 0. And now I can use this quotient rule, right? Because these are the same base, so this subtraction becomes division. So now I can rewrite this as the ln of 3x squared minus 5x plus 2 divided by x squared. And one of the most common things people do is when they rewrite it, they try to write the ln again, and you don't need to because you're rewriting it as division and not subtraction, and this equals 0. So now I'm going to remember that this is a log equation, and I can take a log equation and I can rewrite it as an exponential equation. So the base to the power of 0 equals 3x squared minus 5x plus 2, all divided by x squared. And any number to the 0 power is just 1. And then for lack of space here, I'm going to cross multiply here. So I'm going to take this x squared and multiply it by 1. So I'm going to have 1x squared equals 3x squared minus 5x plus 2. I'm going to give myself a little bit more space down here. And now I'm going to subtract it. I'm going to again set it equal to 0. So 3x squared minus x squared is 2x squared minus 5x plus 2. All right, so I got something quadratic whenever I see that. Now the only way to get positive 2 here and a negative number is going to be 2 negatives here. Oh, no. Let's go back there. I know I want this to be a 1 and this to be a 2. The only way to get 2x squared is 2x and x, because I know if I have minus 4 and then minus 1 more gives me 5. So this equals 0, which means x is going to equal a half and x is going to equal 2. Now we have to go back and we have to check to see that these work. And when we check these, we're going to find out we have to be so careful with the fractions. So let's go back to our original problem here, right? So this is our original problem, and let's put in a half. So we have the ln of 3 times a half minus 2 plus the ln of a half minus 1 equals 2 times the ln of a half. All right, and now I got to deal with these fractions. So I'm going to have 3 halves, right? This is going to be 3 halves. I'm going to go ahead and convert that to 2 to be 4 halves plus the ln of negative a half. I can do that subtraction really fast. 2 ln of a half. So now I'm going to have ln of negative 1/2 plus the ln of negative 1/2 equals 2 times the ln of a half. All right, I keep going. I'm going to have the ln. Now here's where I have to be super careful This is the addition, so this is the product rule. So I'm going to have -1/2 times -1/2 equals 2 times the ln of 1/2. And I know a lot of people want to say this equals itself, but it's not. We're going to see that this doesn't equal. And here's why. If I do the multiplication as a negative, I end up with a positive 1/4. All right, and a positive 1/4 can be rewritten as 1 over 2 squared. This negative can be rewritten as ln of 2 to the -2. All right, and you're going to see that that does not, right? If I want to rewrite this, all right, I can take this -2, and this -2 can come out using the power rule. And we're going to see that when we have a -2, it's different because this is a positive 2. And that's why those two don't equal. And if we try 2, oh, I'm so running out of space here. Let's go down here. It's hard to see our original problem here. So let's try to check the other number. If I have the ln of, let's see, 3 times 2 is 6, minus 2 plus the ln of 2 minus 1 is 1 equals 2 times the ln of 2. Now at least we can go on. We have the ln, the natural log of 4, plus the natural log of 1 equals 2 ln of 2. And this is going to be product, right? So we are going to have the ln of 4 equals 2 ln of 2. I hope you can see that using the product rule, this is going to go there, and you're going to have the ln of 4 equals the natural log of 4. So we said, yes, we proved that this is our solution. This is extraneous in these two examples. Now, that's a lot of work, but it's still pretty cool that it all works out. Now, what I'm kind of telling you through all of this is go ahead and use the graph, right? So they went ahead and they said, let's set this whole thing equal to 0, and they plugged it all into their calculator, and they could see that x equals 2. So using the graph will always help you, but I think the algebra of this is pretty good, and honestly the algebra is really great practice for you when you are going to take calculus, because you need to be able to do this kind of algebra without making mistakes. So why did I do all of this? To show you that you can solve these guys algebraically. And what is your first step? Sorry, let's go back to the problem. What is your first step when you see something complicated? Well, your first step is to use the properties.